Okay, well, we're going to write the equation for a geometric sequence, reminding ourselves that a geometric sequence is t of n equals a times b to the n power. So we're multiplying. And with a I would go table with a geometric, and the bell's going to ring just so that we know. So 0, 1, 2, 3, 4, 5, 6, 7. We need that zero term because that's going to determine the a value. A is the zero term. B is our multiplier. So the fourth term is 48. And the seventh term is 6. So we can say that 6 times 8 is equal to 48, but that means if I'm going this way, I'm cutting it, I'm dividing by something each time. Well, it took me 3 spaces to get 8, so that means 2 times 2 times 2 and times 2 would get me there. So if I'm dividing by 2 or multiplying by 1/2, that's essentially what's happening. So our multiplier is going to be 1/2. Question is, the zero term, how far back do I have to go? It's going to get big kind of quick. So I'm going to take 48, I'm going to multiply it by 2, and that gets me to this 96 right here. And then multiply that by 2, and that's going to get me my 192. And multiply that by 2, and that's going to get me to my 384. And multiply that by 2, and that's going to give me my initial value, 768. That is, again, my zero term, so 768 times 1/2 to the n power. That's my geometric. So the arithmetic sequence is going to be in this form. T of n equals m times n plus b. So if the third term is 12 and the seventh term is 32, I can set up a table again. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, and 7. So the third term is 12. The seventh term is 32. I can see over the course of 1, 2, 3, 4 steps, I've increased by 20. So if I take that 20 and divide it into 4 equal parts, it's increasing by 5 each time. 17, 22, 27, 32. So showing it increased by 5, that tells me my slope is 5. So T of n is equal to 5n. I'd say plus something, but I can see here it's going to actually go into the negative realm. So if I subtract 5, I got a 7. Subtract 5, I got a 2. Subtract 5, I got a negative 3. My zero term, or my initial value, is a negative 3. And so that's that. And while I'm at it, I'm going to do 20 because I'm here. It says that there are 100 grams. Radioactive element decays according to the equation here. Okay, and there's an unknown A and there's a T for time. A is the initial amount, and T is the time elapsed in hours. And that's an important little thing to recognize. 100 grams is what we're starting with. So 100 times 1/10 raised to the T over 24. Now, it's 2 days here, right? And T is in hours. So in 2 days, I've got 48 hours. Now, that might seem like a big number until you recognize that it's over 24. 48 divided by 24 is equal to 2. So that means I can really rewrite this thing as 1/10 squared. Which, I don't even have to grab a calculator here, do I? 1 over 10 squared is equal to 1 over 100. And 1 over 100 times 1,000, we're going to be canceling some zeros, aren't we? That's equal to 1,000 over 100. Cancel, cancel. I'm left with bada bing, bada 10. So that's how many grams are going to remain after 2 days. Boom.